Let's start by opening EasyEDA.com website. So you can download the standalone version for your operating system as well. So I use standard edition. You can also try the other one. And let's start by creating a new project. So I just leave the name of the project as new project. As soon as I create the new project, it will also create a sheet for me. A sheet is where we create our schema. First of all, when we start, we will have to bring in all the essential components to our project. That includes ESP32, S3. So before we do that, there's this common library where you can find all the common components. Let me move this. So yeah, it's limited, and inside library where we searched for ESP32 S3 is where you can find components from everywhere. So you can create your own components, footprints and all that, and save it in your workspace. You can also use components that are available in LCSC. You can also find some in JLC PCB assembled. System for user contributed is where you can find lots and lots of components that are user contributed. So you can create your own component and contribute, and people can find your component. So if I choose LCSC and start looking for the components, I can see lots of them. I would choose any one of them. I think most of them are fine. They should be reliable enough. And also with LCSC, the good thing is you can have the footprint, you can have the schematic diagram, as well as it's sometimes linked to the product page on LCSC, which is really good because then your bill of material at the end will have this automatic link to the product page. So if you're ordering components along with your PCB, or if you're assembling your PCB directly, that will really help you, because then you don't have to manually find the product somewhere and then add to your bill of materials. So this is good. That's why I first go to LCSC and try to find components there. If it's not there, then I would go for user contributed, and user contributed components might not be very reliable because sometimes people post things that are incomplete or with flaws. So if you're using user contributed components, you'll have to keep in mind that you might have to update them to make it work sometimes. So let's place our ESP32 S3 module. I place the central module right in the middle and on the top, because then I can lay out various sub schemas around it. So once we have this, we can now look for another component. I would look for OLED, or I will explicitly mention 64 × 48 OLED I²C. So this is the component we want to use for our OLED screen. This is not what we want. I'm looking on my workspace. This is another LCD screen I actually created myself. What I wanted to do was this. So one of these should work. So the schematic looks fine. I2C requires ground, VCC, SCLSD and reset, and the footprint looks okay to me, and the resolution that's mentioned is correct. So let's go with this. So I can rotate this by using space, so this orientation looks much better to me. So we will just leave it here. and after that we want the keypad, and then I'll go for voltage regulation and all those secondary stuffs. So now I will try to compose a switch or a key on our keypad. So a key on our keypad would be one resistor and one switch like this. So they don't have to align perfectly. For now we'll just place them and we'll take care of wiring at the end. So a resistor and a key is just enough for us. So the resistance value is 1K by default. We want to change that to 330 ohms. We can just leave it as 330. It's clear that it's ohm, and we'll need these ground. The side doesn't matter. I can go any direction, but let's leave it there. And then we want to add nets. So nets, right? Net port. So what happens is when designing schematics, you can create this thing called net port. Let me quickly explain you how it works. So it has a label. So say I want this ground pin. That is not a good example. Let's say IO4. I want IO4 to be called 4, and then if I name this net port the same name, if I give them same names, they are now connected. So if I start wiring this like so, what it means is I'm wiring this resistor to this IO4 port on ESP32. So that's how we will separate these sub-schemas out of the main schema, which makes it possible to have this separate section for different functions. So we will do the same for the screen. So say 5, 6, 7, 8, and VCC and ground, they have this special symbol for them. So VCC, ground, and you use wire and connect this. So this means now we are connecting this OLED to 5, 6, and 7. 5, 6, and 7 is not present yet, so we want 5, 6, and 7 here. So rename them 5, 6, and 7. So that means we have now connected this OLED screen to 4, 5, 6, 7. That's how the net ports work. I will just fast forward from here and I will go to the ready schematic, which I had worked on before as the original work for this project. So what we see here is the ESP32 Room 1 module that we have seen before. We have these tiny mini circuits that are for each key on our keypad. I just made a copy out of one that I created, and then I just made a whole bunch of copies and then updated their names, their net port numbers, and then just used the respective pins here. So 5, 6, 8, 4, 7, 15, 16, 18, 17. So it's important that you use the GPIO pins that are actually free. So not all of the GPIO pins are completely free, so you're not free to choose all of them. For example, IO 19 and 20, they are supposed to be used for USB. If you're not using it for USB, of course you can use it for general purpose IO, but if you're using them for USB, you can't use them for I/O. There are other pins that are connected to internal flash memory or PSRAM or all sort of those things. So if they have some other dedicated task assigned to those pins, you can't use them for GPIO as GPIO. So what we do is we select, let me find my website. Let's open my blog. I had written a blog post about which pins are safe and unsafe. So if you Google for safe and unsafe pins in ESP32 S3, you will probably land on my page, this page, where I list all the pins that are usable without any conditions. There are pins that are unusable, no conditions, you just can't use them at all, and conditionally usable pins, which means there are some conditions. If that applies, you can use them. For example, 0 can be used as GPIO, but the problem is 0, 2 and 5, they are called strapping pins, and they need to be set to high or low depending on how you want to boot your microcontroller. So they need to be in certain state when they're booting, and rest like 35, 36, 37, 39, they probably would be used for PSRAM, or if you're using the flash memory in octa mode, they might be in use already. So if you're not using flash, maybe you can use them. But if you're using flash is always used when you're booting or you're writing to the flash, so it will not be used during the runtime when you're not doing transaction with your flash. So they could be used potentially, but yeah, there are those conditions. If you're using those pins, for example, for LEDs, and then you're writing to flash or reading from flash, then these LEDs will go crazy, because then there will be just data flowing through those pins, and you know, it will just maybe make some show there. Otherwise, unusable pins are those you don't want to touch, so you just leave them alone, just ignore them, forget about them. And there are other pins which so ground, 3v3 and enable are quite clear. You can't use EN. I should have just put it on unusable pin, because EN is a reset pin. So if it's grounded, your microcontroller is turned on. If it's high, then it's reset. So your microcontroller will just shut down. That's how it works. So this should be actually unusable. But it has its own name, and it's clear that it's there for some purpose. So that's kind of clear. And the rest of these here, they're I probably just never used them, and I'm not sure how usable they are. If you're using AI Thinker ESP32 board, the pin layout looks like this. I didn't have other development board or other custom board I could use for my module, so I just used this cheap one, which was made for ESP32, but I use it for ESP32 S3. Works just fine. There are a few pins that are missing, and everything is really scrambled, so it's not in perfect order. But the important pins like power pins, enable, transfer and receive for UART, so UART communication is lined up very well, and it is the same for all room or rover modules. So if you see here, TX, RX, TX, RX, TX, RX, TX, RX, so they have the same kind of order there, so it's quite convenient. So you can use other modules on the same board, and you'll have the same order of these pins. So back to our schematic. So now that's out of the way, we have pins. So the way I chose 5, 6, 8, 4, 7. So I have used 4 actually. So it should be usable pin. I have it on gray. No, actually usable pin. Sorry. Okay. So we have selected the pins that are usable, and we use them for all our I/O purposes. 5, 6, 8, 4, 7, 15, 16, 18, 17 is used for keypad. We have used 1 and 2 for I2C communication. So there's a thing called I2C bus. So you can connect as many, I think 256 different components that uses I2C communication on the same pins. Some don't even have reset, but some have. And you just need power pins and the 2 pins for SCL and SDA, the clock and data pin. So you just need those 2 pins to connect 256 components, different modules. So they can be sensors, they can be displays, they can be anything. So we have used one I2C out here. So this is labeled I2C. It's a simple header with 2.54 pitch. This will be used for gyroscope or accelerometer. That will make it an air mouse, and the same pins are used for OLED display here. And we have broken out virtually all pins into different categories. Like most of them are just as is. So like however the pins come out of the module, we just align them in the same way, so that we don't have to work on complex wiring. So it's just simply coming out of the module, and we're just putting a pin out headers. So those are those, and I have used one for power header. So it's 3v3 battery in and 2 grounds. So this is for extra power usage, like if you want another module that doesn't conveniently have access to power rail or power pins, you can use these. VBAT can be used to directly connect to 3.7 volt lithium ion battery or more. So it can be up to 5 volts or even more. So we are putting this LDO in between. So the VBAT will be input here, and then VBAT is not actually input. The 5 volt is the input, and there's a fuse. Let me check where VBAT is. So yeah, here VBAT is connected to the switch. 5 volt is the output. It can be coming from USB or it can be coming from V battery. So V battery, when V battery is connected to 5 volt, this is sourced from V battery. And when it's switched to VUSB, it will be connected to VUSB, which is the input that we're getting from the USB here. So USB port will be connected there, or the battery will be connected there. So that way we can power it using USB or using the external battery. And both ways it will go into our LDO and it will turn it into 3.3 volts, and that's what our microcontroller needs. And this 3v3 is used as VCC for all our stuffs. Like this is directly connected to 3v3 on ESP32, and whenever we want to do something like these decoupling capacitors or these filter circuits, this is a delay circuit that we need for proper booting. What else? Here the power is also supplied for OLED. Same for the programming breakout. So yeah, that's how we have distributed the power stuff. So that's header, that's display. We have already discussed keypad, we have already discussed, and basically ESP32 is just connected to all these net ports, and however we want to use those net ports, we will use them in our sub circuitries. So let's move on to power. I've already talked about power and USB. So USB, I haven't completely covered this. So VSP, as you saw, is the power input that's coming from USB port. V- is connected to ground, and then there are D- and D+, which is connected to this 0 ohm resistor, which then is connected to D+ and D-, 19 and 20, D- and D+ of the ESP32. That's just basically it for USB connection to our ESP32. So ESP32 can directly use USB connection, can be used as USB to UART. It can also be used as USB host. So you can host other peripheral devices like camera, microphone, whatever uses USB. So in our case, we're using it as the input from USB host. So this will be connected to a computer, and then we'll use this as USB to JTAG to program the ESP32. And the reason why we have these 0 ohm resistors are because we want to remove them if you don't need D- and D+. So we could use UART to program this ESP32. So we could release these D- and D+ and use USB plainly for power purpose, and then use D- and D+ pin as normal GPIO. So if you're running out of IO pins, this is a way to create more IO pins. So 2 more IO pins, but the thing is you will have to use this header to program it. And for secure programming, UART is recommended to program ESP32 rather than USB to JTAG. So in any way, yeah, you could even use D- and D+ for peripheral devices, and then use this to program it. So whatever is your requirement. And on our LDO again, we have these C2 and C1 10 microfarad capacitors, which are decoupling capacitors. We'll have to place them properly on our device. We will look at that when we get to PCB design. On 3v3 of our ESP32 as well, we have 2 decoupling capacitors, one of 22 microfarad and one of 0.1 microfarad or 100 nanofarad. So these are important to filter out high frequency and low frequency noise that may be produced by, for example, USB, or when there is some external noises in the environment. So all that can be filtered out by these capacitors. So the function of the ESP32 is reliable. So the part that is left is this here. So we have I think I already mentioned this is a delay circuit for reset. So this is required to properly boot the device, and it uses 1 microfarad of capacitor and 10 kilo ohm resistor. We have an LED. I have 7.5 kilo ohms resistor as current limiting resistor, which I prefer to have bigger value so that we don't waste more energy in LEDs. I prefer not to even have LEDs, but yeah, we want to have an LED to show it's turned on. But I would most of the time remove LEDs to save power, or use a very high value resistor to limit the current so that we're saving some. And then we have this boot thing, which is IO0 pin that we want to be able to connect to ground whenever you want to boot the ESP32 in programming mode. While you're using UART, it's required you press the IO0 and reset, and that will boot ESP32 in programming mode, and you can then start programming it. Otherwise, also when your ESP32 has just come out of the factory and it hasn't been programmed once, it will also need this sequence. So you will ground IO0, you will reset, and then your ESP32 will boot in programming mode. We have switch, which is, as I already explained, switching between VUSB and VBAT. VBAT is directly connected to 3.7 volt lithium ion battery or external batteries that gives you around 5 volts, and VUSB is the voltage that is coming from USB, and depending on which power you want to choose, you will switch between them. And if you're on USB, you will switch to USB, and if you have your battery connected, you will switch to VBAT. And this one here is a reset button. So as I said, if you want to reset this chip, you'll just press this button. And 0.1 microfarad capacitor, not really sure, it's recommended design, so I have that there. So that's pretty much the whole schematic. So hope that was informative, helpful. If you have any questions on any of this, you can add a comment on this video. Otherwise, that's all about schematic design for our project. Thank you for watching.